Hey guys, yesterday we looked at finding the length of an arc using radians, and the formula was S equals theta times the radius. So in problem number 1 for warm-up, they gave you a radius is 6 feet and the theta was pi over 3. Now all you had to do is plug it in, and 6 feet times your pi over 3. I put a 1 under and multiply across, making it 6 pi over 3, which turns into 2 pi. 2 pi is the answer, but if you plug in 2 pi in your calculator, you end up with approximately 6.28. So approximately 6.28 feet is your answer. It makes a little more sense if you're talking about it is to put it in decimals, because 2 pi feet doesn't really, when I think about feet, I don't know what 2 pi feet really means. But if I make it 6.3 feet, that makes a little bit more sense. Now, moving on to problem number 2. And when you're looking at problem number 2, we've got a little bit of a problem. We can't do this formula with a degree. So the very first step is I would take the degree and turn the degree into a radian by multiplying it by pi over 180. If you do that math, you end up with, we could reduce by 5s. If you reduce by 5s, you get 27 pi over 36. And then you can continue to reduce. 9 goes into 27 3 times. So it's 3 pi. And 9 goes into 36 4 times. So it's a 3 pi over 4 for the radian. Now that we know the angle as a radian, we can plug it in. So plugging it in now, we're just multiplying the angle times the radius. The radius they told us was 10, and now the angle is 3 pi over 4. If we multiply, that's going to give us 30 pi over 4. We could reduce it, but most of the time I don't really even reduce because I'm going to plug it in my calculator. And we end up with a 23.56 answer. Now it was in feet, and this is only the length of the arc. So it is just, it's like circumference. It's a piece of circumference when you talk about the length of an arc. If I drew a little diagram, it's like going from just a little piece around. So it is just in regular feet when you find it, because it's like circumference. Now let's move on to problem number 3. And in problem number 3, the directions change, and it tells you to find the area of a sector. And the formula for area of a sector is 1/2 the theta times the radius squared. Okay, so that is our little formula for the area of a sector. And in problem number 3, it gives the radius is 5 feet and the angle is 5 pi over 4. So I'll just plug it in. Theta is 5 pi over 4, and the radius is 5. Don't forget to square the radius, because the formula does have it r squared. 5 squared is 25. I usually stick a 1 under it because of all the little fractions in this problem, and then I just multiply across the top. And when I multiply across the top of it, 5 times 25 is a 125 pi. And across the bottom, 2 times 4 times 1 is just an 8. This is our answer, but if we went to get the decimal, do 125 pi and divide by 8, and you get a 49.09. Only this one was area, so this one is feet squared. So either of those answers would be correct, but just keep in mind that you're finding an area of a sector, which means you're finding like a whole slice of pie. Okay, when you talk about area, you're finding that whole chunk. Okay, now we had one more to do, and it was problem number 4. They gave us the radius is 4 feet, and the angle was 135. Well, luckily we already know that 135 is 3 pi over 4, and we did that just a moment ago. Right here, we converted it, okay, and got that answer. Okay, so 135 is 3 pi over 4. So we're going to need the radian for our problem, and if we plug it in 1/2, the angle is 3 pi over 4, and then we do the radius squared. Well, remember that radius squared, 4 squared is 16, and then I just really multiply across the top. So I made my 4 squared 16. If I multiply across the top, 3 times 16 is 48, and I carry over the pi. 2 times 4 times 1 is 8. 48 divided by 8 is 6 pi. 6 pi is the answer, but if we put that in our calculator, we get about an 18.85. And remember, we did area. So since this is an area problem and we were in the unit of measure feet, it is feet squared. So this is your answers. Questions on the warm-up of area of a sector or arc length. Okay, that was just kind of reviewing what we did in class yesterday. Now I'd like you to turn to your page 13, and we're going to do a little review. We're also going to use 14 and page 15 a lot in class today. So a few things to remember. When you do sine, it is the y, and cosine is x. Tangent is y over x. Remember the ordered pair that we usually write as x comma y. It is really sine, it is cosine comma sine, because cosine is your x and sine is your y. Now, we filled in several of these last week. I didn't finish the whole chart. It was kind of meant for you guys to do for practice. But I'm going to go ahead and fill in a few. We said that 180 is pi. That's the radian. If the point is located at -1, 0, and they're referring to the point on the unit circle. So let me pull that unit circle back up. So 180 is pi, and it's located at -1, 0. Well, we said cosine is the x, so now we can go to our chart, and where it had the cosine, we can fill in the x, which was -1. For the y, it is the 0. And then if we do the, tangent is the y over x. If we do y over x and reduce, well, 0 divided by any number is 0. So the tangent of 180 is 0. You could even test a few of these out in your calculator by pressing tangent of 180. Just make sure you're in degree mode. The mode, remember, is found up here. You can tell when you look at that part of your calculator, that top part. Now, to kind of keep this going, well, we knew that 270 on that unit circle, and I can kind of flash back, 270 was located at 0, -1. Now, we wrote that already on our little chart here, and remember, this was the sine. Sine is your y, and cosine is your x. And tangent is the y over the x. Well, when 0 is on your denominator, it is undefined. Okay. There's only a couple that we did not cover, and I want to go back to the unit circle and look at our 30 and our 60. Now, when you're doing your 30, and I will draw it on some notebook paper to help, just so you can look at it individually, and I won't mess up our unit circle. When you go 30 degrees, that meant our angle right here moved away. It swung up 30 degrees. They're just kind of writing it out to the side. But 30 degrees, if you're looking for that point, you drop a 90, and then you have this 30, 60, 90 triangle. Now, I wrote down in our last video, I wrote down that your favorite two triangles when you're doing 30, 60, 90, it is a 1, the short leg is 1/2, and the long leg is radical 3/2. I told you your favorite 45, 45, 90 was 1 for the hypotenuse, and the legs were radical 2/2. Now, if you think about this triangle, and now let's go back. So short leg is 1/2. Well, short leg, the hypotenuse is the radius of the unit circle, and we did talk about the radius of the unit circle is always the value 1. So our short leg would be the 1/2. It's half the size. And long leg is the radical 3/2. So if we're plotting this point, we moved out the x-axis only a distance of radical 3/2. We went up the y-axis 1/2. And that is our answer for the 30. Now, it's kind of cool to see, and I don't know, paper folding, if we paper fold it over, there is a 30 right here. If we kind of paper fold down this direction, you get the 30 here and the 30 here, which happen to be at 150, 210, and 330. All of these answers will follow what the 30 did over here. So it's going to move a radical 3/2 and then 1/2, a radical 3/2 and then 1/2, and this one's also a radical 3/2 and then 1/2. The problem is in this quadrant, where the 330 is, x is positive but y is negative. In quadrant 2, where the 150 sits, it went to the left and up. The x is negative because left is negative, but up is positive. The 210 went left and down, so left and down are both negative. And these are your answers that we're going to put on the unit circle, and these are all the things that are 30. They all have a 30-degree reference angle. Now, let's go back to the unit circle and write those in officially. So we know that a 30 is a radical 3/2 and then 1/2. I'm just going to put those in to the 330, to the 210, and the 150 like we just discussed. Remembering that the 150, the x is negative but y is positive. At the 210, they're both negative. At the 330, only y is negative. And now we have all the 30s. Okay? Now, let's talk about the 60 for a moment. I'm going back to my clean paper. I'm going to redraw. And if we graph where 60 would kind of sit, 60 would swing this direction. Okay? So a 60 would kind of look like that, and if we're looking for that point, we would drop a 90. And then it would create a 30, 60, 90 triangle. with the radius from the center to the side being the value 1 because it's in our unit circle. Then because the 30 is the short leg, 1/2 would be here. And then the other one would be the radical 3/2. So if we're looking at a 60, it really went and traveled out the x-axis only 1/2. And it traveled up the y a radical 3/2. And these are your answers for the 60. Now, but like the 30, the 60, if you fold it over like this, there's a 60 here. If you fold them down, there's a 60 here and here. The 60 that's located here, we call it really 120 because it's a 60 away from the 180. And down here, 60 away from 180 would be 240. So 240 is going to have the same answers as the 60 did, as the 120 did. In the last quadrant, the 60 would be 60 away from 360, which means it would be the 300. So these four answers, the 60, the 120, the 240, and the 300, all have the answers where it's the x is 1/2 and the y is radical 3/2. So let's go back to the unit circle and fill this in. So we said x is 1/2 and y is radical 3/2. I'm at the 240. Now I do want to make a note up here at the 120. X, remember, is a negative, but y is positive. At the 240, when we write those in, remember in that quadrant, x and y are both negative. And at the 300, x is positive, but the y is negative. Now, and that's really what they say in these charts down here, the trig values. The trig values is to say that sine is y, cosine is x, and tangent is y over x. In quadrant 1, sine, cosine, and tangent are all positive. Everybody's positive. Remember how I said all students take class? All of them in quadrant 1 are positive because your x's and your y's are positive. In quadrant 2, okay, x is a negative and y is positive. So if you think about the chart down here, x is a negative in that quadrant, but sine is a positive. And since tangent is a y over an x, it is negative in the second quadrant. If you're talking about the third quadrant, okay, x and y are negative, so sine and cosine are both negative, but tangent is y over x. And what happens when you have a negative over a negative? It turns positive. So in quadrant 3, both sine and cosine would be negative answers, but tangent would happen to be a positive in quadrant 3. Quadrant 4, okay, think about quadrant 4. Aren't our x values positive, but our y values are negative? So sine is the y, sine is negative in quadrant 4, cosine is positive, and if we do a y over an x, a negative over a positive is a negative. So tangent would be negative if we're in the fourth quadrant. You can also remember that I taught you all students take class, and it means that all of them are positive here. Sine is positive in quadrant 2. Tangent is quadrant 3. It's positive. And cosine is positive in quadrant 4. This really helps out in other problems. But now our unit circle is totally finished. We have a little bit to fill out on page 13, so let's finish filling this one out. we already have the point, and if you look at your unit circle, the 30 is the radical 3 over 2 and then 1/2. The 60 is this one here, and the 60 was the 1/2 and then radical 3 over 2. So I've got those. So my y of the 30 degree is 1/2. And the x is the radical 3 over 2. I'm just filling that in. The 60, the x is 1/2, so that's your cosine is x. Sine is your y, so y was radical 3 over 2. Now, 30, and we can use our formula for converting radians into radians by multiplying by pi over 180. And if we multiply by pi over 180 to convert it, your zeros cancel. You'll get 3 pi over 18. 3 goes into 18, though, 6 times. So pi over 6 is the radian that matches the 30 degree. If you do that again with the 60 and convert it to a radian by multiplying by pi over 180, your zeros can cancel, and you get 6 pi over 18, which reduces to pi over 3. So 60 degrees is the same as pi over 3 radians. Now the last part is finding their tangent. Now, on a 30, the tangent, remember, is your y number over your x. And in this case, 30, the y number, it happens to be 1/2. And the x is the radical 3 over 2. Now, there are many ways to do this math to show it. I like to do the outside-inside trick. If you multiply the outside numbers, you get 1 times 2, which is 2. If you multiply the inside numbers, you get 2 times radical 3, which is 2 radical 3. The only problem is you have to simplify it, and you're not allowed to leave radicals on the denominator. So we multiply by radical 3 over radical 3. You end up with a 2 radical 3 on top. On bottom, you have a 2 times really the square root of 9, which turns into 3. Your 2's will cancel out the 2's, leaving you a radical 3 over 3, the answer for tangent of 30. So let me run back to our chart, and it's a radical 3 over 3. That is the tangent of 30. Let's do the tangent of 60. Okay. So tangent of 60, remember, is the y over the x. This time, if you're looking at the 60 location, the y is the radical 3 over 2, and the x is the half. If we multiply your outside, we get 2 radical 3. If we multiply the inside, we get 2. The 2's cancel, and your answer is radical 30. So the tangent of 60 is just radical 3. And now we have all of our 13 complete and our unit circle complete. And now I'd like us to move over to page 14. Sorry, I skipped a page accidentally. And on page 14, quadrant 1, we kind of said this already, all things are positive. Quadrant 2, sine is positive. Quadrant 3, tangent. And quadrant 4 is cosine is positive. You can write these down. And I kind of skipped to problem 5 with the class. I know some students are feeling really overwhelmed with the unit circle. And I want to just talk to you about things that you need to know to do these problems successfully, okay? So I don't want you to carry around the unit circle and feel like you have to rely on it. We don't need to make copies and use it every time we do math. Now, it's good to have as a reference page to look at occasionally if you get a little sidetracked or just want to double check an answer. But truly, this is all that you need to know. You need to know that cosine is x. You need to know sine is y. You need to know where the 30 is on the unit circle, where the 45 is, and where the 60. You should know the four quadrennial points, the 90, the 180, the 270, and the 360. Those you should know the location of as well. But remember, they only go out to 1 and up to 1. So those are usually easy for students to find. So these are the ones that you need to kind of memorize. The 45, you need to know that it is located at a radical 2 over 2 and a radical 2 over 2. They match. Usually students are really good at remembering the 45 location on the unit circle. The 30 and the 60 are very similar. They use the same two fractions, but you need to know which one goes with which one. I like to say the 30, it starts with the radical 3 over 2 and then 1/2. It's a 30, see 3, it starts with the 3, the radical 3 over 2. And then the 60 just flips that. So the 60 is the 1/2 and then the radical 3 over 2. If you guys can remember this, you really don't have to know the whole unit circle. Okay? Now, I'd like us to now answer some of the questions on page 14. So I started the class looking at number 5. And if we look at problem number 5, it's a 150. Now, I'm not going to go and refer back to that unit circle, okay? Feel free to look if you would like to, but I'm going to think about where is a 150. A 150, if I'm thinking about its location, is in here. And if you think about a 150, how far is it from 180? How many more degrees do I need to go to get to 180? 30 more degrees. Well, 30 is what they call your reference angle. And it is going to use the same answers as the reference angle. So we should now know that it is the radical 3 over 2 and then 1/2. This is the 30 answers. If we can pull the 30 answers, now we can go back and say the question is sine. Well, what is sine? Y. And if sine is y, then we're going to go here and we're going to pick out the 1/2. Now, there is one other thing that I look at, and is the 1/2 going to be positive or is it going to be negative? Well, isn't the y in this quadrant a positive? And the second quadrant, the y is up here, so the y is positive. So the answer is positive 1/2. And you have just finished problem 5. Let's do the tangent of 300. Now the tangent of 300, I would think first, where is 300? So I would kind of sketch where a 300 kind of sits. And it goes around and sits in here, in the 4th quadrant. How far is the 300 from being 360? Only 60. So the reference angle is a 60 degrees, which means, we know where it's located. It's a 1/2 and then a radical 3 over 2. And now I go back and think, well, we're doing tangent. And tangent is a y over an x. So I'm going to put the y, which is radical 3 over 2, over the x, which is 1/2. And I like to then do outside, inside. If I do the outside multiplied, it's going to give a 2 radical 3. If I do the inside multiply, I get a 2. Well, the 2's cancel, and I get the answer radical 3. But now I need to think about the location that it sits. And it sits in the 4th quadrant. Now, you could go back and think about all students take class. And in the fourth quadrant, cosine is positive. But guess what that means tangent is? Negative. Because cosine's positive, not tangent. So tangent would be negative in that quadrant. Now, we can do any on this page. I was going to keep doing a few more. But you guys can start getting me to do certain ones if you see one that looks a little bit scary. I'd like to go on and do number 7, even though I feel like it's an easier one. I'd see the 225 and I would first think, where is 225? 225 is in here. How far away is it from 180? 45 away. So it's going to do what the 45 did, which is a radical 2 over 2, radical 2 over 2. And because it's x, you guys are doing the x number. What's the x number? Radical 2 over 2. Now, in that quadrant 3, is the x a positive or a negative? Think about this location. Negative, because it's left and down. So x is negative, so we've got our answer. It's a negative radical 2 over 2. Now in other classes, they wanted to see a radian answer. So let's do number 8, and then maybe we'll skip to one of the radian answers. I'd like to do number 8 because it says something that we haven't dealt with lately. It says to do cotangent of 315. Well, again, the first thing I'm going to do is try to find where is 315, and isn't it in the middle of quadrant 4? If 315 kind of swings around to the middle over here, it is how far from being 360? Yes. So the reference angle is a 45, which means we know x and we know y. They're both radical 2 over 2's. Now, cotangent, I don't really know cotangent, but I do know what tangent is. And tangent is y over x. So guess what cotangent is? X over y. Very good, because it's the reciprocal. And if we take the x number and put it over the y, we have a radical 2 over 2 over a radical 2 over 2. What would that give us? Isn't that the same number divided by itself? It's a 1. But then I would check the sign. And isn't that x positive but the y is negative in that location? Okay, so our x was positive but our y was negative. What happens when we have a positive over a negative? Our answer is negative for number 8. Negative 1 was our answer.
Why do you figure negative sign all the way up there? Is it just like because you didn't have enough room?
Yeah.
Okay.
Now, I didn't want it to blend into the equal sign. Now, let's look at problem 11. Now, when I see a problem like number 11, the first thing I'm going to do is, what in the world is 11 pi over 6? I'm going to do 11 pi over 6 and convert it to a degree. Now, remember that pi really is 180. So I'm going to, in my calculator, type 11 times 180 and divide it by 6. The answer is, it is a 330 degree angle. So this is really 330. Well, then if you think about where a 330 is going to be located, it is really close to being 360. How far away is it from 360? Only 30. So the reference angle is a 30. And we know that 30 is a radical 3 over 2 and then the 1/2. Now it said to do cosine. Well, cosine is the x. So I'm going to pick out the x answer, radical 3 over 2. And then I'm going to check, is x positive or negative in this quadrant? Positive. So our answer is positive, and we've finished. your assignment is to finish page 14 and page 16. And to make sure that you have pages 1 through 20 complete, I would recommend review the warm-up from Monday, where we reviewed 45, 45, 90, 30, 60, 90, and the trig, the basic little trig, see one hippie, catch another hippie. The quiz that was supposed to be on Monday will be on Friday. I just wanted you guys to know ahead of time. And let me know if you have any problems.